Hello, and welcome back to EpperlyNotes. Today we will be covering Differential Equations, Lesson 1. So, Lesson 1 is simply just the introduction to differential equations. A differential equation is an equation with a derivative in it, a rate of change. And examples of something like this could be something like the stock market or population, for example. And there are two main types of differential equations. There is ordinary and partial. Ordinary is only ordinary derivatives appear in the differential equation. Partial is the derivatives in the equation are partial derivatives, which if you haven't learned about partial derivatives, do not worry. Next, there is order. The order of a differential equation is the order of the highest derivative that appears in the equation. For example, in this problem, t cubed times d squared y all over dt squared plus t dy dt plus 2y equals sine t, the order in this differential equation would be the order of 2, and that is because of the d squared y over dt squared. Next, there's linear versus nonlinear. A linear problem is just all variables to the first power. There's no multiplied variables. This is simply like an example of that would be x plus y equals 7, or even something like y over x equals 1. That is a linear problem because it can be algebraically solved to be linear. Next is nonlinear. Nonlinear is pretty much anything that is just not linear. An example of this for a differential equation could be y double prime plus 2y prime times y equals t. This is nonlinear because the y prime is multiplied by y. So now, let's solve a quick example where we're going to talk about solutions to differential equations. We need to verify that y of t equals c1 sine 2t plus c2 cosine 2t is a solution to the differential equation y double prime plus 4y equals 0, where c1 and c2 are arbitrary constants. Find values of the constants c1 and c2 so that the solution satisfies the initial conditions y of pi over 4 equals 3 and y prime of pi over 4 equals negative 2. This problem is actually quite easy. It may sound confusing at first, but we will work through it. So we are given the equation y equals c1 sine 2t plus c2 cosine 2t. All we need to do is find the first derivative and then the second derivative of that problem. So we're finding y prime, and then we're going to find y double prime. So y prime of this equation using the chain rule, would be 2c1 cosine 2t minus 2c2 sine 2t. So now we can use the chain rule once again to find the second derivative of this, which is what we really wanted to see. Y double prime equals negative 4c1 sine 2t minus 4c2 cosine 2t. That is the second derivative of y. So now we can say that y double prime plus 4y is equal to negative 4c1 sine 2t minus 4c2 cosine t plus 4c1 sine 2t plus c2 cosine 2t. And now we can conclude that that is all equal to 0 after some algebra. So now how do we find the values of c1 and c2 in this problem? Well, it's actually simpler than you realize. We are given that y of pi over 4 equals 3, and we already have a y equation. So we're just going to simply say y of pi over 4 equals c1 sine 2 times pi over 4 plus c2 cosine 2 times pi over 4 equals 3. This will simplify down to C1 being equal to 3. That is just a coincidence that y times pi over 4 equals 3 and C1 equals 3. Purely coincidence. So now we need to find the value of C2. So now we have y prime times pi over 4 equals 2C1 cosine 2 times pi over 4 minus 2C2 sine 2 pi over 4 equals negative 2. So if we simplify that down, we will be left with negative 2 C2 equals negative 2. So we can now say that C2 is equal to 1. And the solution to this problem would be y equals 3 sine 2t plus cosine 2t. Now, why is that the solution? Because all we did was we found the values for C1 and C2 and plugged it back into the original equation of y. So after that, we got our solution to that problem. I think it is very important to note now that if you need to brush up on your calculus skills, such as taking the derivatives and finding integrals, now would be a perfect time to do so. So another good thing to note is that when you're solving something like y prime equals 3 minus 2y squared, we are solving for y equals f of t. The t is not seen in that original equation, but we can assume that it is there with the y. They are always together. So now let's do a much harder example than that first one. We need to verify that y of t equals cosine of t, ln cosine of t plus t sine of t is a solution to the differential equation y double prime plus y equals secant of t. So this equation is obviously going to be much harder. It's going to involve trigonometry, product rules, and a chain rule. So let's get started. Y prime equals cosine of t times negative sine of t over cosine of t plus ln cosine of t times negative sine of t plus t cosine t sine of t. We can see at the beginning of this equation that the cosines will cancel out with each other, leaving us with negative sine of t. So if we simplify down y prime, we would be left with negative sine of t, negative sine of t plus ln cosine of t plus t cosine of t. So now we need to find the second derivative. Y double prime equals negative sine of t times negative sine of t over cosine of t plus ln cosine of t times negative cosine of t plus t negative sine of t plus cosine squared t over cosine. This will simplify down to y squared equals sine squared t plus cosine squared t all over cosine of t minus cosine t ln cosine of t minus t sine of t. And knowing that sine squared t plus cosine squared t equals 1, that whole beginning of that equation is just 1 over cosine of t, leaving us with y double prime equals secant of t minus cosine of t ln times cosine of t minus t sine of t. So if you do not know where that secant came from, it came from the 1 over cosine of t. So now, if we look back at our original equation, it said y double prime plus y equals secant of t. Well, we already have that secant of t, which is a great sign. So if we just add y, which will be equal to cosine of t ln cosine of t plus t sine t, we would actually get the answer. Y double prime plus y equals secant of t. Thank you for watching this video. If it helped you, please consider to like and subscribe. Thank you.